Hello, this lesson is about reflections. The title of our lesson is Reflections. And let's start with some vocabulary. How about the definition of what a reflection is? A reflection is the process of flipping a figure. Reflection is the process of flipping a figure. And we are going to look at a few examples of how you actually reflect figures. So let's start with example 1. Example 1 says, graph the pre-image and image, then write a rule to describe the transformation. So let me give you some coordinates that we are going to graph. The pre-image is A, B, C, D, and our pre-image happens to be a square. A is located at -3, -1. B is -2, -1. C is -2, -2. And D is -3, -2. Let's go ahead and graph that. -3, -1, we'll label that as A. -2, -1 is B. -2, -2 is C. And -3, -2 is D. And then you'll see that this is a square. We'll connect the dots. This is a square. Okay, and then our image, A prime, B prime, C prime, D prime, okay, is A prime is 3, -1, B prime is 2, -1, C prime is 2, -2, and D prime is 3, -2. Okay, so let's graph those. 3, -1 is A prime. 2, -1 is B prime. 2, -2 is C prime. 3, -2 is D prime. Okay, so when you first look at it, it kind of looks like a translation. It almost looks like the figure just shifted over to the right. But that's not what happened, because over here I have A on the left and B on the right. But over here I have the flipped version of that. B on the left and B prime on the left and A prime on the right. So it looks like we went from AB to BA over here. That's a flip, which means it's a reflection. So we've done this part. We have graphed, but now we're supposed to write a rule. So a reflection has happened. I can tell from the graph, but it's easier to write the rule just by looking at what happened from A to A prime. So compare. We went from -3, -1 to become 3, -1. Looks like 3, -3 became +3. And nothing happened to the y values. So the x value went from being negative to positive. And this is how we write that. The x value changed signs. It went from -3 to +3. So to say that, I can just write -xy. The negative means the sign changed, because the x value changed signs. This is the answer. -xy. That is the rule that we were supposed to write. A figure can be reflected over the x-axis, can be reflected over the y-axis, the line y equals x, the line y equals -x, and an infinite number of other lines, such as x equals 7 or y equals -3. So you can reflect over lots of different types of lines. Okay, so let's look at another example. This one says, graph the pre-image and image, then write a rule to describe the transformation. Again, we're going to do some graphing. So we're going to graph QRS, which is a triangle. Q is -3, 1. R is -2, -1. S is -4, -1. Okay, so let's graph -3, 1, -2, -1, and -4, -1. And then we're going to graph the image. So this was the pre-image. We're going to graph Q prime, R prime, S prime. Q prime is 1, -3. R prime is -1, -2. And S prime is -1, -4. So let's graph 1, -3, -1, -2. That's R prime. And -1, -4. That is S prime. Okay, so it looks like these letters have been turned around a little bit. I see an S here and S here. R is really close to R prime, and Q prime are this relationship to each other. It's interesting that R and R prime are so close to each other. It's because they reflected over a line that's really close. Okay, so actually we've reflected over this line here, and it might be hard for you to see this if this is the first time you've seen this type of reflection. Let me try to draw this as a dashed line. This is a reflection over the line y equals x. Okay, so this is the line y equals x. If you did not know that, it wouldn't matter. You can still answer the question. It says write a rule. So we're going to look at the actual numerical values of the points that were given. So it looks like if I compare S and S prime, let's compare those two. It looks like we went from -4, -1 to becoming -4, -1, -4. So the x value became the y value, and the y value became the x value. So the x and y values swapped positions. Okay, so let's write the rule for that. Let's actually answer the question. How do I write that x became y and y became x? Yx. Instead of writing xy, I have y comma x. That's how you can say that this was a reflection over the line y equals x. Okay, let's look at another example. Okay, so let's look at example 3 this time. All right. Example 3 says reflect the figure over the line y equals -1. So let's go to the y-axis, which is this vertical line, find -1, and then you're going to draw a line that passes through that point. It has to be a horizontal line. Y equals is always a horizontal line. Okay, so let's look at the pre-image and go ahead and graph that. The pre-image MPR. So M is -4, 2. P is -2, 3. and R is negative 1, 2. Okay, so we have a triangle, and we're going to reflect this triangle over this purple line that I drew down here. All that you have to do is count the distance from the point to the line. So let's start with M. 1, 2, 3 units away from the line, and then I'm going to make it 1, 2, 3 units away from the line on the other side. That's M prime. P is 1, 2, 3, 4 units away. So let's go on the other side of this horizontal line. 1, 2, 3, 4 units on the other side. That's P prime. And then R is 1, 2, 3. 3 units on the other side as well. 1, 2, 3. R prime. Okay? So it should look like if you were to fold this picture in half on this line, this would overlap perfectly onto this image here. Okay, so we have answered example 3. Let's look at another. Example 4 says, reflect the figure over the line y equals x. Let me scroll back up. Okay, hopefully that's better. Reflect the figure over the line y equals negative x. Go ahead and graph the points. M is 1, negative 1. L is 4, 1. And K is 4, negative 1. Okay, and connect the dots to make the triangle. Okay, and then we're going to reflect over y equals negative x. If you're not sure what that line looks like, let's review just for a second. Slope-intercept form is y equals mx plus b. This looks a lot like this. We've got y equals negative 1x. I added a negative 1 in here. It was just negative x. It's actually negative 1x. There's a coefficient of negative 1 there. And if I wanted to add in what this b value is, it's 0 because there's nothing being added here. So that means the slope is this number here. Remember, slope was rise over run. And this is the y-intercept, 0. So I'm going to go ahead and graph the y-intercept. It's 0. The whole point of what we're trying to do is we're trying to figure out how can I graph this line so I can reflect the figure over it. Okay, and then the slope we said was negative 1, which is actually negative 1 over 1. So I'm going to fall 1 and go to the right 1. So starting from this point, I'm going to go down 1, right 1, down 1, right 1. You plot points as you go. Down 1, right 1. Down 1, right 1, down 1, right 1, up 1, right 1, up 1, right 1, up and, left, up and left, up and left. So if you're thinking, well, that's really complicated, it's really not that big of a deal because you can memorize that the line y equals negative x always looks this way. It goes through all these corner points of the boxes. All these corners, so it always passes through 0, 0, and then you're going down and right into this diagonal corner here to create this downward sloping line. You see how it has a negative slope? It's a downward sloping line. So the next thing we're going to do is we're going to graph this in the easiest way that I know possible, which is to count the diagonal distances away from this line. Okay, so you see how M is located on the line? That means that M prime is in the exact same position. It's not going to move. That makes it easy for us. The next thing we want to look at is K. Here's K, and if I go diagonally to the next corner, let's see if I can make dots so you can see. One diagonal box this way, and then a half of a diagonal box that way. Okay, and then I've reached the purple line. So to get on the other side, I want to have 1.5 diagonal boxes on the other side. We're going to end up right here. Start on the purple line. Here's a half of a box and then a whole box. Here is my point. Half of a box, a whole diagonal box. So here's my new point, and that is K prime, which is located at 1, -4. Okay, M prime is still at 1, -1. The only one left is L. Okay, here's L. I'm going to go diagonally across one whole box, diagonally across 2 boxes, diagonally across a half a box. So I've gone across 1, 2, and a half, and now I have reached the purple line. So I want to go a half, 1, 2, and I end up here. So a half. Let's do that one more time. 1, 2, and a half. And I'm right here. A half, 1, 2. And I'm here. That is L prime. And I'm going to connect the dots. And L prime is located at -1, -4. A little hard to see. It's a little bit squished in here. And if you notice, look carefully. Doesn't it look like if you were to fold this picture in half on the purple line, that this would overlap perfectly onto the blue image? It kind of looks like a butterfly. So you should always get the butterfly effect when you're reflecting. Okay, let's review these rules. A lot of students prefer to memorize the reflection rules. I'm not a big memorizer. I find that challenging for myself. But a lot of students like to have this written down somewhere. If you're reflecting across the x-axis, okay, this is the rule. You are going to change the sign of the y value. Okay, so that's a little bit messy, but it says x comma y with an arrow, x comma -y. That means change the sign of the y value. If you reflect across the y-axis, it's the opposite. You change the sign of the x value. Okay, so that would be -x comma y. And then if you reflect across y equals x, the trick is you change the positions of x and y comma x. If you reflect across y equals -x, there's a trick for that. I could have done that, used this rule for example 4, but I decided not to. I wanted to show you a different way. The rule for this is switch the positions and change the signs of y and x, and you will get the same answer as you do when you count in this way. Okay? All right. We have a couple of practice examples. This would be an excellent opportunity for you to pause the video and try these on your own. I'm going to go ahead and answer the questions. Okay, so the first practice example says, reflect the figure over the line x equals -2. Go to the x-axis, find -2, and draw a line that crosses through that point. It should be always, if you see x equals, that is always a vertical line. Should be vertical. Y equals is horizontal, always. So now I just need to count from each point to the purple line. Okay, start with O. 1, 2, and then count 2 on the other side. 1, 2, and put a dot. That is O prime. For P, I'm starting here and I'm going to count to the purple line 1, 2, 3. And on the other side, 1, 2, 3. And I'm going to put a point. Z, I'm going to count 1. And then on the other side, just 1. And label that Z prime. And then go ahead and connect the dots. And I did not do a good job of drawing straight lines. But if you notice, you could fold the paper in half here, and each of these would overlap perfectly like a butterfly. Here's our last example that we're going to look at. It says write a rule to describe the transformation. So I don't actually have to know what I'm reflecting over. I know it's a reflection. It looks like it's flipped. I could just look at the points. It looks like I went from 3, -2 is m, to becoming 3, +2. It looks like the y value changed from being negative to positive. The y value changed signs. X comma negative y. Okay? Or maybe you know that this is a reflection over the x-axis, and maybe potentially you have memorized the rule for that, which is just to change the sign of the y value. That's the end of our lesson on reflections. Thank you so much for watching.